Welcome to lecture number 8 in our series of lectures on trigonometry. The topic of this lecture is product form of sum and difference of two trigonometric functions. I am your lecturer, Professor E.O. Efanga. Sum and difference of two sines. Show that 1. Sin x plus sin y is equal to 2 sin x plus y over 2 cos x minus y over 2. Please observe that for the sum of two sines, we have sin cos. 2. Sin x minus sin y is equal to 2 cos x plus y over 2 sin x minus y over 2. Also observe that for the difference of two sines, we have cos sign here. Proof. Recall that sin A plus B is equal to sin A cos B plus cos A sin B. Let us number this as equation 1. Also recall that sin A minus B is equal to sin A cos B minus cos A sin B. We number this as equation 2. For number 1, let us add equation 1 and 2 to obtain sin A plus B plus sin A minus B equal to 2 sin A cos B, since cos A sin B minus cos A sin B will cancel out. Now, let A plus B equal to x and A minus B equal to y. Solving these two equations simultaneously yields A equal to x plus y over 2 and B equals to x minus y over 2. So therefore, sin x plus sin y is equal to 2 sin x plus y over 2 cos x minus y over 2. For number 2, we subtract equation 2 from equation 1 to obtain sin A plus B minus sin A minus B equal to 2 cos A sin B. Putting A plus B equal to x, A minus B equals to y, A equals to x plus y over 2, and B equals to x minus y over 2. We obtain sin x minus sin y equal to 2 cos x plus y over 2 sin x minus y over 2. Example 1. Express in product form A sin 60 degrees plus sin 70 degrees. B sin 60 degrees minus sin 70 degrees. Solution. A. Sin 60 degrees plus sin 70 degrees is equal to 2 sin 60 degrees plus 70 degrees over 2 cos 60 degrees minus 70 degrees over 2. And this will give us 2 sin 65 degrees. 60 plus 70 over 2 is 65. Cos 60 minus 70 over 2 is minus 10. But cos minus 10 is equal to cos 10. So this is equal to 2 sin 65 degrees cos 10 degrees. B. Sin 60 degrees minus sin 70 degrees is equal to 2 cos 60 plus 70 over 2 sin 60 minus 70 over 2. This is equal to 2 cos 65 degrees sin minus 10 degrees. But sin minus 10 is the same thing as minus sin 10. So this is equal to minus 2 cos 65 degrees sin 10 degrees. Example 2. Express sin 28 degrees cos 32 degrees as sum or difference of two sines. Solution. We recall that sin A plus B plus sin A minus B is equal to 2 sin A cos B, where A is equal to 28 and B equals to 32. So if you put A equals to 28 here and B equals to 32, this will give us 2 sin 28 degrees cos 32 degrees equal to 28 plus 32. That would be sin 60 degrees plus sin A minus B, that is 28 minus 32. That will give us minus 4. That's plus sin minus 4 degrees. Dividing both sides of this equation by 2, we have sin 28 degrees cos 32 degrees equal to 1 over 2 into sin 60 minus sin 4 degrees, since sin minus 4 is equal to minus sin 4. Example 3. Express cos 65 degrees sin 85 degrees as sum or difference of two sines. Solution. We recall that sin A plus B minus sin A minus B is equal to 2 cos A sin B. Putting A equals to 65 and B equals to 85, we have 2 cos 65 degrees sin 85 degrees is equal to A plus B. 65 plus 85 will give us 150, so that will be sin 150 minus A minus B. 65 minus 85 will give us minus 20, so that will give us sin 150 degrees minus sin minus 20 degrees. If we divide both sides of this equation by 2, that will give us cos 65 degrees sin 85 degrees is equal to 1 over 2 into sin 150 degrees plus sin 20 degrees, since sin minus 20 is minus sin 20, so that minus will change this one to plus. Sum and difference of two cosines. Show that 1 cos x plus cos y is equal to 2 cos x plus y over 2 cos x minus y over 2. Please note, for the sum of two cosine, we have cos here. 2 cos x minus cos y is equal to minus 2 sin x plus y over 2 sin x minus y over 2. Please note, for the difference of two cosine, we have a negative sign here and we have sin. Proof. Let us recall that cos A plus B is equal to cos A cos B minus sin A sin B. Number this equation 1. Also recall that cos A minus B is equal to cos A cos B plus sin A sin B. We number this equation 2. So to obtain the sum of two cosine, we have to add equation 1 and 2. So adding equation 1 and 2 will give us cos A plus B plus cos A minus B equal to 2 cos A cos B, since minus sin A sin B plus sin A sin B will cancel out. Now let A plus B equal to x and A minus B equal to y. Solving these two equations simultaneously yields A equal to x plus y over 2 and B equal to x minus y over 2. Putting them into our equation, we obtain cos x plus cos y equal to 2 cos x plus y over 2 cos x minus y over 2. Next, subtracting equation 2 from equation 1, we obtain the difference of two cosine as cos A plus B minus cos A minus B. And this will give us minus 2 sin A sin B. Putting A plus B equal to x, A minus B equal to y, A equals to x plus y over 2, and B equals to x minus y over 2. We obtain cos x minus cos y equal to minus 2 sin x plus y over 2 sin x minus y over 2. Example 4. Express in product form A cos 70 degrees plus cos 40 degrees, B cos 35 degrees minus cos 105 degrees. Solution. A, for the sum of two cosine, cos 70 degrees plus cos 40 degrees is equal to 2 cos 70 plus 40 over 2 cos 70 minus 40 over 2. And this is equal to 2 cos 55 degrees cos 15 degrees. B, for the difference of two cosine, we have cos 35 degrees minus cos 105 degrees is equal to minus 2 sin 35 plus 105 over 2 sin 35 minus 105 over 2. And this is equal to minus 2 sin 70 degrees sin minus 35 degrees. But sin minus 35 is equal to minus sin 35. That minus will change this one to plus to give us 2 sin 70 degrees sin 35 degrees. Example 5. Express cos 40 degrees cos 120 degrees has sum or difference of two cosines. Solution. We recall that cos A plus B plus cos A minus B is equal to 2 cos A cos B. Let us put A equal to 40 degrees and B equals to 120 degrees. Then we will obtain 2 cos 40 cos 120 is equal to cos 160, that's A plus B is 160, plus cos minus 80, that is A minus B, is minus 80 degrees. Dividing both sides of this equation by 2, this will give us cos 40 degrees cos 120 degrees is equal to 1 all over 2 cos 60 degrees plus cos 80 degrees. Please recall cos minus 80 is the same thing as plus cos 80 degrees. Example 6. Express sin 65 degrees sin 85 degrees as sum or difference of two cosines. Solution. We recall that cos A plus B minus cos A minus B is equal to minus 2 sin A sin B. Let us put A equals to 65 degrees and B equals to 85 degrees in this equation. This will give us minus 2 sin 65 degrees sin 85 degrees is equal to cos 150 degrees, that is cos A plus B, minus cos minus 20 degrees, that is cos A minus B. Dividing both sides of this equation by minus 2, we obtain sin 65 degrees sin 85 degrees is equal to minus 1 over 2 into cos 150 degrees minus cos 20 degrees, since cos minus 20 is equal to cos 20. And this will give us 1 over 2 cos 20 degrees minus cos 150 degrees. That is, if you multiply through by minus 1, this sign will change to plus cos 20 degrees, while this one will change to minus cos 150 degrees. We have come to the end of our lecture. Thank you for watching and keep on watching.